this video, we're going to take a look at Unit 5 and the study guide that went along with it. If you don't remember what Unit 5 is, it was basically when we had that formula sheet and we were using it to solve for surface area, volume, perimeter, the area of composite figures, all of those things. Before I get started on any of these problems, I want to show you where you can look to find that formula sheet. So if we just switch windows and go over to Google, in order to find your formula sheet, if you just type in Math 8 SOL formula sheet, click on the very first thing that comes up, and that is the formula sheet that you're going to use. The first 6 formulas are all for perimeter and area of 2D shapes, and then the next 4 are 3D shapes and finding the surface area and the volume, and then you have the Pythagorean theorem, what pi is equal to, and then a bunch of abbreviations. So you can refer to this as I go through the video. I'm not going to click back and forth because I have most of these memorized because I've been doing it for so long, but you're always free to glance at this, have it open as you're working, and it'll be a really good resource for you to use. So, getting started, we're just going to go one problem at a time, solving for each of these things. So the first problem asks us to solve for the perimeter. Remember, perimeter means around the outside of the shape. So we're going to have to add all of the values on the outside of the shape. So we need to figure out what all those measurements are. If this side is 18, the one across from it is also going to be 18 yards. And then the radius of that circle is 9 yards. So what that means is if you go from the center to the outside at any point, so from here to here, is going to be 9 yards, which means if I go in the other direction, it's also 9 yards. If we add these together, we find that that whole side is equal to 18 yards, which means that the side across from it is also 18 yards. So this is actually a square. And then the last value we need is the circumference of this semicircle. So if you look at your formula sheet and you go to the circumference of a circle, you'll see 2 different things. You'll see that circumference is equal to 2 pi r, and you will also see that circumference is equal to pi times d. You can use either of these formulas, it's really up to you. I'm going to use 2 pi r because it gives us our radius. So I'll put 2 pi times the radius of 9. So to find the perimeter of the entire shape, I need to find that circumference, and because it's only a semicircle, I actually need to divide it by 2. And then I'll go over to Desmos and I'll just plug it in. So I'll put my fraction bar first, and then 2 pi times the radius goes on the top, divided by 2 because it's half of a circle, and I get 28.27 yards. So that's this outside length right here. So to find the perimeter of the whole thing, I just go one side at a time. So I'm going to start right here and go around the shape. So my first side is 18 yards, so that accounts for this one, plus another 18 yards, plus another 18 yards, plus the circumference of that semicircle. So this one right here. What I have to remember is that I do not want this inside length because it is not on the outside of the shape, which is what your perimeter is. So then you can just go over to Desmos and add those numbers together. So 18 plus 18 plus 18 plus 28.27 gives me a perimeter of 82.27 yards. In my next problem, I'm finding the perimeter once again. This one is a little bit harder because I'm going to have to use the Pythagorean theorem. So I'm first going to plug in the numbers that I know, the easy ones to find. This side right here is the other side of that rectangle, so I know that it's going to be 3 inches. And then I need to find this side length of the top, which is going to be the same as the one across from it. In order to do that, I'm going to split my triangle, and then from the top, I'm going to draw another line. And now I have a right triangle. If this entire side is 4 inches, then half of that is going to be 2 inches, and then I'm told that my height is 2. And I'm just going to write that on the inside of the triangle as well. And then I can use the Pythagorean theorem. So the Pythagorean theorem says that a squared plus b squared is equal to c squared. So my c is the side across from my right angle, which is the side that I have to solve for. So I'm going to plug in my a, and I'll plug in my b, and then I'll go to Desmos, and I'll do 2 squared plus 2 squared to see what that's equal to, which is 8. And then in order to find what c is, I'll take the square root, and the square root of 8 is going to be about 2.83. So now I know what those diagonal lengths are. And with that knowledge, I can find the perimeter of my composite figure. I'm going to start right here, and I'm just going to go around the outside. So my first side is 3 inches. My next side is 4 inches. Another 3, and then 2.83 plus 2.83. And now if I add all of those together, I can find my perimeter, which is going to be 15.66 inches. I think this is probably one of the harder perimeter problems you're going to see because a lot of us struggle with the Pythagorean theorem, and finding those missing sides is one of the more complicated things that most of us face. But we're now going to move on to area. When we're doing an area problem, I like to split it up into the shapes that I have. So in this composite figure, I have a rectangle, and I have 2 semicircles. So I have one here and one here. If I put those together, I have one full circle, so I'm going to say plus a circle. You could do plus 2 semicircles, but really it ends up being the same thing. And then I'm going to look at my formula sheet, and I'm going to write down the formulas for a rectangle and a circle. So my formula for a rectangle is length times width, and for a circle is pi r squared. And now we're just filling my missing values. So for my rectangle, my length is going to be 30, and my width, I use the radius of that circle, which is 10, to figure out the width of the rectangle. So the radius is the center to the outside, so that means from there to there is 10 feet, and same thing in the other direction. So then the width of the entire thing is 10 plus 10, or 20. And then for my circle, I have pi r squared, where r is equal to 10. And then to find my area, I just plug all of that in exactly how it is. So 30 times 20 plus pi r squared. And I get 914.16 feet squared as my answer. In my next problem, I'm going to do the same process, but I have new shapes. I have a triangle, and I have a semicircle. My formula for a triangle will be 1/2 base times height if I'm solving for area. And for a semicircle, a circle is pi r squared, and because a semicircle is half of that, I just divide it by 2. And then I'll plug in my values. The base of my triangle is this bottom length, which is going to be 6 inches. The height is how tall it is, which is 13 inches. The radius of my circle is 6, and I'll divide it by 2. So then I'll go over to Desmos, and I'll type in that whole thing. 1/2 times 6 times 13 plus pi r squared divided by 2. And I find my area is 95.55 inches squared. Then I can move on to my next one. For my next two problems, you'll notice I have a shaded section and then a piece that's taken out. Whenever I have a problem like this, what I'm going to do is I'm going to subtract my shapes. So my outside shape, the shaded in one, is a square. And I'm subtracting those 4 circles. If I look at my formula sheet, the area of a square is s squared, and a circle is pi r squared. And notice I multiplied this by 4. The reason I did that is because there are 4 circles. And then I plug in my values. So s stands for the side of the square, which is 10. R is my radius, which is 2. And I'll just plug it in. So 10 squared minus 4 pi times 2 squared gives me an answer of 49.73 inches squared as the area of the shaded shape. And then lastly, I'm finding the shaded area of this rectangle when the triangle is taken out of it. So my rectangle will be length times width, and my triangle will be 1/2 base times height. So the length of that shape is this entire side, which is 12, and the width is that side, which is 7. And then for my triangle, when I do 1/2 base times height, the base of the triangle is just this bottom section, which is 5. And the height is if I go from the top and I go straight down. So it's not 8 because that's the slant, but it's how tall the whole shape is, which is going to be 7 inches. And then I just plug it in. So I have 12 times 7 minus 1/2 5 times 7, which gives me 66.5 inches squared as my answer. And then I have a couple word problems that are really asking me to do the same type of thing, just I have to figure out if I'm looking at perimeter or area. In this first problem, it basically tells me right out. It says that George needs to put wood trim along the perimeter of the room, which means I'm solving for perimeter. And the trim costs $3.75 per foot. How much will it cost George to buy the trim? So the first thing I need to do is I need to solve for the perimeter, which means I need to find my missing sides. If this entire side is 24, that means that this entire length would also be 24. But I don't want the whole length, I just want from here to here. So I need to take the 24 and take away this section that's only 10 feet. So I'm subtracting. 24 minus 10 is going to give me 14 feet. And then I'm going to do the same thing to find this little section right here. So the whole thing, if this whole thing is 16, then so is this whole thing. But if I take away this section that's 12, 16 minus 12 is 4. So now I can find the perimeter of my shape. So my perimeter is just adding all the sides. So I'll start right here. My first side is 24 plus 16 plus 10 plus 4 plus 14 plus 12. So then in Desmos, I'll add all those together. 24 plus 16 plus 10 plus 4 plus 14 plus 12. And I get a perimeter of 80 feet. But I'm not quite done because it asks how much it will cost to buy the trim. So if it's $3.75 per foot and I'm getting 80 feet, I need to multiply those numbers together. So I'll do 80 times 3.75, and that tells me that it's going to cost $300 for George to buy the trim. In my next question, Samantha is buying fertilizer for the grass in the backyard. She has one bag of fertilizer that will cover 3,000 square feet of lawn. Does she need to buy another bag? So there's two ways to know what you're doing. Number one is it says square feet or square foot. So anytime you have a square unit, that means you're dealing with area. The other way you can know is that if you're buying fertilizer, you're trying to cover up the whole yard, not just around the outside. So anytime you're filling something in, you're dealing with area. So I want the area of the shape. You can cut it several different ways. You could cut it this way, where you have 3 different shapes. You can cut it this way, where you once again have 3 different shapes. Or you can do it how I'm going to do it, and you can make one big rectangle and take away this smaller section right here. So I'm going to do it that way, where I'm having a big rectangle and I'm subtracting the small rectangle. So both of them will give me length times width minus the other length times width. So for my big shape, it's 60 by this side, which is 70. So I'm going to do 60 times 70. And then for my little shape, I have one side right here, which is 20, minus this other side, which I don't know. But I do know that this entire thing is 70. So if I take the 10 and I take the 20 away, that's 70 minus 10 minus 20. I get a side of 40 feet. So then I can plug this equation into Desmos. So I'll do 60 times 70 minus 20 times 40. So altogether, that is 3,400 square feet, which means that Samantha does need to buy another bag. And then we'll move on. So that takes care of all of our area and perimeter of 2D figures. And we're now going to look at what happens with changing attributes of rectangular prisms. So whenever you're dealing with a rectangular prism and we're looking at the volume, whatever you do to one side is how the volume is going to be affected as well. So what I mean by this, if we look at this problem, it says that Josh has 2 rectangular prisms. The length of the second prism is 10 times the length of the first, but everything else is staying the same. What best describes the volume of the second prism? So if I'm multiplying by 10, just one side, my volume is also going to be multiplied by 10. And I'm going to quickly prove this. Say I have a rectangular prism that's 1 foot by 1 foot by 1 foot. Volume is length times width times height, which is going to be 1 times 1 times 1. And that's not a 1, that's a 10. So the volume would be 1 cubic feet, 1 cubic foot. If I was to take the same shape and change one of the values, so instead of it being 1 foot long, I'm going to make it 10 feet long, make it 10 times bigger, but everything else stays the same. It's still length times width times height, but now it's going to be 10 times 1 times 1, which is going to be 10. So this number is 10 times larger than this number, which is the same as what I did to my side length. So if it's 10 times bigger in one of the sides, then the volume is also going to be 10 times larger. So if I look at the next problem, my scale factor is how much bigger it's getting. So the volume of prism A can be found by multiplying the volume of prism B by what scale factor? To get from 3 to 6, I'm multiplying by 2, so that's my scale factor. And it's that simple. And now I'm going to move on to my surface area and volume, and this will be the last page that you guys have to do. So my first problem wants me to find the surface area of a cone. If you look on your formula sheet, it tells you that surface area is equal to pi r squared plus pi r L, where r is the radius and L is the length of the slant. What you have to be careful of is that sometimes it'll give you 2 values. It'll also tell you this height right here. You have to recognize that L stands for the slant. I like to think of it as if I had a person standing on the top of that cone. If they slid down the side, that is the slant. But anyway, let's go ahead and solve this. All we have to do is plug in our values. So our radius is 2, so we'll plug it in whenever we see an r, and our slant is 6. And then we can plug it into Desmos exactly like this. So we'll do pi r squared plus pi r L. And that'll give us our surface area of 50.27 meters squared. So surface area will always be units squared. For our next problem, we're asked to find the volume. The volume of a cone is going to be 1/3 pi r squared h, and that's on your formula sheet. Where r is our radius, so it's half of the distance across the circle, and our height is h. And let's plug that in. 1/3 pi. R is only half of 8.8, so if we took 8.8 and divided by 2, we would get 4.4. So that's our radius. And our height will be 11.2. And then we'll plug that into Desmos. So 1/3 times pi times 4.4 squared times 11.2 will give us our volume of 227.07 inches cubed. And then our next two problems, we have to figure out if we're doing surface area or volume. And our first one, it says that Janet has a sculpture in the shape of a large cone on her living room shelf. The cone is 2 inches in diameter, 8 inches long, and has a slant length of 10 inches. She wants to paint the sculpture. Does she need more paint? So in order to do that, we need to find the surface area, because if you're covering something, you're just going around the outside, which is surface area. So surface area formula is pi r squared plus pi r L. So we'll plug in the numbers we know. So the diameter is 2 inches, which means our radius is half of that, which is only 1. And our slant, because L stands for slant length, is 10. So we'll plug that in to Desmos. So pi times your radius squared plus pi times your radius times your slant is 34.56 inches squared. If she has 35 square inches, no, she does not need more paint. The next problem says that Cindy went to Maggie Moo's for an ice cream cone after school. The ice cream cone had a radius of 3 inches, a height of 7.5 inches, and a slant length of 8.5 inches. 1 scoop of ice cream is 50 cubic inches. Could the cone hold it? So if you're dealing with an ice cream cone, anytime you're trying to fill something, that's going to be your volume. So we're going to solve for volume here, where the volume formula is 1/3 pi r squared times h. So it tells us that our radius is 3 and our height is 7.5. And you can either put 7.5 or you can put 7.5. Doesn't really matter. I'm going to put 7.5. Actually, it's a little bit easier to put into Desmos. So then I just need to solve. So I have 1/3 times pi r squared times my height, which is 70.69 inches cubed. So if one ice cream cone is 50 cubic inches, then yes, the cone can hold all of it. And then lastly, we have the surface area and the volume of square pyramids. So the first problem, we're going to find the surface area. If you look on your formula sheet, the surface area is 1/2 LP plus B. Before we get started, two things. First thing is L still stands for slant, so it's still the side of your shape, and the height is still if you're going straight up or straight down. And then the second thing is about this P and this B. So the P is the perimeter of your base. So if you go around the outside of this square, that entire distance is your P. So if one side is 4.7, so is the other, and the last. So to find the perimeter of the whole thing, what you're really doing is you're multiplying one side by 4. For the area of the base, that means if you're to shade in this whole thing, it's the area of that square. So you're taking one side and multiplying it by the other, or you're doing 4.7 squared. When I substitute in, I'm going to go ahead and substitute in with this knowledge. So my slant is my side, which is 6.6. And if my perimeter is 4.7 4 times, it's 4 times 4.7. Because instead of just going 4.7 plus 4.7 plus 4.7 plus 4.7, I can just multiply it by 4. And then the area of my base, B, is going to be 4.7 times 4.7, or 4.7 squared. So I'll go to Desmos and I'll plug it in just like this. I'll do 1/2 times 6.6 times my perimeter, which is going to be 4 times 4.7, plus the area of my base, or 4.7 squared. So the surface area is going to be 84.13 inches squared. For my next problem, my volume problem, the volume of a square pyramid is going to be 1/3 the base times the height. And I'm finding my base just like I did a second ago. So my base is going to be one of the sides squared. So it'll be 3.5 squared. And then my height is 3.9. So I'll go over to Desmos and I'll do 1/3 times 3.5 squared times 3.9. And that'll give me 15.93 inches cubed as my volume. For my next problem, the jewelry store has 2 large glass models of diamonds in the front window. Each one is shaped like a square pyramid. Model A's base is 6 inches on each side and 9 inches tall. Model B's base is 4 inches on each side and 12 inches tall. Which model required more glass to make? So if there are glass models, you're only making it with the material around the outside. So you're going to find surface area, where surface area is 1/2 the length times P plus the area of the base. So we're just going to fill in those numbers for both Model A and Model B and see which one is larger. For Model A, your slant is 9 inches. Your perimeter is going to be 6 times 4, or 4 times 6. And then the area of your base is that side number squared. For Model B, it'll be 1/2 the slant of 12 times 4 times the side length, which is 4, plus the side length squared. So remember, when I'm doing this, or this, the reason I'm multiplying the base by 4 is because I'm solving for the perimeter, which is just one of the sides times 4 because it's a square. So I'll plug it in. 1/2 times 9 times 4 times 6 plus 6 squared. It's going to be 144 inches squared for Model A. And then for Model B, it'll be 1/2 times 12 times 4 times 4 plus 4 squared, which is 112 inches squared. So Model A is going to need more glass to make. Then our last question, Ms. Bryant has 2 pyramid-shaped boxes. Box A has a height of 10 inches and a square base that is 4 inches long on each side. And box B has a height of 4 inches and a square base that is 10 inches long on each side. She told her students they could choose one box to fill with free candy. Which box should they choose? So anytime you're filling something up, once again, that's going to be volume. So the volume of a square pyramid is 1/3 base times height. So we're going to find box A and box B. For box A, the base is 4 inches, which means the area of the base is going to be 4 squared, and the height is 10 inches. For box B, the base is 10 inches, which means the area of the base is 10 squared, and the height is 4 inches. So we just have to solve for both. For the first, we'll do 1/3 times 4 squared times 10, and we get 53.3 repeating inches cubed. And then for box B, we'll do 1/3 times 10 squared times 4, which is 133.3 repeating inches cubed. So I would definitely recommend they fill box B with candy because it holds quite a bit more. And that's the end of this unit. Hopefully you found it helpful. Feel free to reach out if you have any questions.